Had a minor problem in class today, minor embarrassment. I think my head was congested in addition to just having this cold, but my brain was congested as well, or my mind was congested. And somebody had asked me, why are or how are we going to know that the good inferences are the good ones and the bad inferences are the bad ones? That is, why is the pattern on the right invalid? I mean, the point is, you told me modus ponens, MP, the positive direction rule, left to right. If P, then Q, P, therefore Q. You said that's valid. The truth of the premises guarantees the truth of the conclusion. But why isn't that true of the what I'm calling now the evil twin, reversing the second premise in the conclusion here? If P, then Q, Q, therefore P. And the way you can show that a pattern of argument is invalid, or that an argument itself is invalid, that it's of a pattern that's invalid, is to show that it's not a valid one. A valid one is one in which it's impossible to fill in the pattern so that at the same time the premises are true and the conclusion is false. So by contrast, if you can, for the one on the right that I'm claiming valid, which I'm saying we can, if it is possible, if we can fill in the pattern so that the premises are true and the conclusion's false, then it's invalid. So the question is, how do we do that? Well, let's consider an example. We've been calling this kind of thing a counterexample to show the invalidity of the evil twin of modus ponens up there. And let's think about two sentences. P, Legum is a dog. Q, Legum is a mammal. It's just an example. Don't think too hard about it. Let's stick to the point at hand. The first premise of modus ponens would say if Legum is a dog, if P, then Legum is a mammal. Right? All dogs are mammals, so if anything's a dog, then it's a mammal. That one was true. The second premise is Legum is a mammal. Well, humans are mammals, right? Therefore, conclusion, Legum is a dog. You might not be happy with me today, or you might be using a dog as, man's best friend. He's my dog. Well, I'm talking about a dog, arf, arf, that kind of dog. That one is false. So we now have an example where the premise is true. First premise is true, because if I'm a dog, then I'm an animal, and then I'm a mammal. Second premise is true. I am a mammal, but 3, conclusion's false. I'm not a dog. So we filled in the pattern so that the premises are true and the conclusion's false. So that proves that the argument is invalid. Now, let's quickly think about modus ponens. I'm going to tell you, and you can spend some time trying to do this to prove me wrong. Don't spend a lot of time. That you can't fill in a P and a Q such that you're going to get two true premises and a false conclusion. Try a few examples. As I said, don't spend a lot of time. I could make you the silly offer that I'm going to give you an A if you can do it, but believe me, it can't. Or don't believe me, try it, and then when you get a little frustrated, it cannot be done. But I showed you with the evil twin it can. Let's go over to modus tollens and see the same thing is true. Modus tollens, MT, the negative direction rule. If P, then Q. We're starting negative, not Q. Then we can go in the negative direction, therefore not P. I said that's a good rule, but the evil twin of MT, if P, then Q, not P, therefore not Q, is an invalid inference, a bad inference. And again, I'm saying the one on the right, impossible to fill it in so the premises are true, the conclusion is false, but I can prove that the one on the left, modus tollens, is such that the one on the left, modus tollens, is such that it's a valid one, so it's impossible to fill in those P's and the Q's so you get two true premises and a false conclusion. But by contrast, the one on the left, modus tollens, I'm telling you, is a valid pattern. MT, the negative direction rule, if P then Q, not Q, therefore not P. So what I'm saying by that for the one on the left is that it's a valid pattern. You can't fill it in that way, but by contrast, the one on the right, highlighted in a shade of red, is invalid, not valid. So it will be possible to provide a P and a Q that makes both premises true and at the same time the conclusion false. And in fact, here's the counterexample, and we can use the same P and Q before. P being Legum is a dog, Q being Legum is a mammal. And here's the argument. Legum is a dog, then Legum's a mammal. Legum's not a dog, therefore Legum's not a mammal. Well, first premise is true, same way it was in the last example. Second premise is true because I am not a dog. But the conclusion's false. Look, I'm a human, and just like all humans, I am a mammal. So the argument and the pattern are invalid. The conclusion does not follow from the premises. By contrast, consider modus tollens, the good inference. You can't supply, if P then Q, not Q, therefore not P. You are not going to be able to come up. It's impossible to supply a P and a Q that are both true at the same time that conclusion is false. As with the last one, try a few examples. Don't spend too much time because you're not going to find one. I could give you the silly, again, the silly promise. If you can do it, you get an A in the course. Don't waste your time. There are better ways of spending your time. You can get an A in the course, but not this way.